Hello students, welcome back. My name is Dolon Banerjee and we are continuing with the same geotechnical engineering video lectures organized by the AKTU. Okay. So, last time we were carrying out some numerical problems based on the index properties of the soil. So, as I told you, we will be incorporating some more indices of these index properties so that they can be used as numerical concepts as well. So, today we will be continuing with the same. Okay, so our objective again will be to problems related with the index properties. This is the numerical problem based on the shrinkage limit. Okay, shrinkage limit. So, let us see what is given to us and what we are to find. The values of liquid limit, plastic limit, shrinkage limit of a soil were reported as below. WL is given, WP is given, WS is given. So, these three parts are already given to us. If a sample of this soil at liquid limit has a volume of 40 cc, what is 40 cc means 40 cubic centimeter. Okay, its volume measured at shrinkage is 23.5 cc. Okay, it always obviously it will decrease. You know the chart, something like this. Okay, so here it is more, here it will be less. Determine the specific gravity of the solids. What is the shrinkage ratio and volumetric shrinkage? Okay, so what are the things given at liquid limit? This is the water content and this is the volume. Again, at shrinkage limit, this is the water content, this is the volume. Okay, and plastic limit, only water content is given to us, no volume is given to us. Okay, so this is the basic overview of this question. So now we will follow a step by step procedure. First of all, let us understand this whole question in diagrammatic or in phase diagram. You just now saw that the water content for liquid limit will be 60, again for shrinkage is 20. So, if you remember what was water content, it was WW upon WS. Okay, if it is 60% means its 0.6 is equals to WW upon WS, which means W we will be converting into WW. Okay, so WW will be 0.6 WS. Is it okay? So this part which was the WW is converted directly into 0.6 WS. Similarly, this one, in this case W is again WW by WS. Okay, so this is given to be 20%. So WW upon WS. So we can say that WW will be 0.2 WS. Okay, so this is also there. So these are the diagrammatic representation. This is WS every time, just this is reducing slowly and slowly. Okay, and after that, if you remember, after shrinkage no volume reduction takes place, so this is only occupied by air. Okay, so this is the diagrammatic or phase diagrams. So now let's see further. Now what we will do, we know this diagram. Okay, this graph we know. Here these all are given to us and two of them means this and this is given to us, this is not given to us. So first of all we will find Vp. Okay, how? You know that this is a single line, straight single line. So the slope will be equal everywhere. We omit this one. Okay, slope of AB is equals to BC. What is slope? If you remember formula for slope, y2 minus y1 upon x2 minus x1. This is the slope of any line. Okay, so the same formula is used here. So you can see for AB, if you consider this minus this upon this minus this. Okay, so we get this part. Again for BC, what will be this? WVL minus VP upon WL minus WP. This. So we get here. Now we solve for this VP. Just solve it to get the answer. This one. Just general solving. No, there is not such, because with 0 we can cancel the 0 as well, and just 3 multiply here and just solve it. Okay, just solve it. We get it 27.6 cc. Okay, so this is the volume of at which point? At plastic state. Okay, when the soil is at plastic limit, the volume of that soil will be Vp, which is this much. Okay, now we have all the volumes and all the water contents. Let's move forward. Then what we will now do at shrinkage limit. Okay, at shrinkage state, what they have done, they have used the equation this one. Okay, So just put your values. You already know what is V, what is Vs, okay, total volume, and what is at the shrinkage limit, and Ws you know, okay. So you can just put the values to find out Ws, okay. This is Ws, means this is the solid weight, okay, this is the solid weight. This is done. Now finally Gs you know already. This another form, it is written in the terms of Vs. If you write this in the terms of Vs, what will be this? Ws upon Vs, and this is gamma W itself. So from here we have found out the Vs, okay. So this is converted like this, okay. They have been bifurcated and we have converted it like this. So taking common, what Ws upon gamma W is taken common from both of them, so we get this one, okay. Vs you know, Vs we have already calculated, okay. So just put the value of Ws in that equation, okay, and Gs is this much, so we get the value, okay. From this equation, after putting the value of Ws, what we get? The value of Gs to be 2.7. What is Gs? It is the specific gravity of soil solids, okay, soil solids, okay. Then what is shrinkage ratio? I told you in the last class what is the shrinkage ratio. Here we will be using this formula for the calculation of shrinkage ratio, because we are not provided with other parameters which we generally require to find out the shrinkage ratio. So here shrinkage ratio we will be just finding out by gamma D upon gamma W, okay. So you can straight away find this, okay. Then finally volumetric shrinkage. What is volumetric shrinkage? It is just the difference in two, mainly the shrinkage limit, okay, between this, and you can take it as a liquid limit or this also. Here we will be using liquid limit, okay, so that we can use the shrinkage ratio. So just actually Vs upon Sr is W1 minus W2, okay. So just this formula has been used here, and we have calculated it to be 0.74 in percentage 70.4%, okay. So this is your question. Just you have to remember some formulas only, it is not that much complex. This is a new formula for you, okay, you can note it down, okay, and this is also, if you want, you can note it down. It is also a compressed form for the formulas of volumetric shrinkage and shrinkage ratio, okay. Now let us see further. Now this is on the shrinkage ratio question, okay. Let us see what is asked in this question. First of all, again let us read the question. Plastic limit of the soil is 25%, its plasticity index is 8%, okay. This is IP given to us, and this is plastic limit, okay, WP is given to us. Then when the soil is dried from its state at plastic limit, the volume change is 25% of its volume at plastic limit. Means when we start to decrease the water content from plastic limit, okay, to this, when we move in this way, then what happens? The volume change is 25% of its volume at plastic limit. Means the volume of at plastic limit, if it is Vp, as soon as we move from here to here, its volume changes by 25% or 0.25 fraction, okay. From here to here 25% volume decrement will be caused. Then similarly, the corresponding volume change from liquid limit to dry state is 34% of its volume at liquid limit. Means from here VL to, if we decrease from here to here, means Vs, how much decrease is there? 34% decrement can be seen, okay, because it is written to dry state. So from here we have to go up to Vs, okay. So here it is 25% and here it is 34%. This much information is given to us corresponding to the volumes, okay, at different states. Determine the shrinkage limit, shrinkage ratio, okay. Two things are to be determined. So again we are given with WP, IP, okay, and WL. So this much things are given to us. WL can be calculated from this only, okay. WL minus WP is 8 given to us, WP is given to us already, so just WL is found out. Now again just we can use the slope again, just in the previous question as we did, just the slope of this line, again we will use the formula y2 minus y1 upon x2 minus x1. Okay, this formula we will be using. So VL minus VP upon WL minus WP is equal to VP minus VD, or VS also you can say it, upon WP minus WS. Okay, this formula we have obtained from the same slope formula. Then see, this was what I am talking about at VD, from this 25% reduction and 34% reduction, which means it was, what was it written there, something like this, you can take it like this. Okay, from here, from, if this is VL and this is VP, this is VS, from here to here 34% reduction, okay, decrement, and from here to here 25% again decrement. Okay, so just we have done 1 minus 0.25 and 1 minus 0.34, okay, into what, the volume this. Okay, so we get these volumes at Vs or Vd also, you can, here it is represented as Vd, you can say it Vs or Vd. Okay, so now again we go back to the same formula, means this one, this formula, we again move to this formula and place the values of Vd in terms of Vp. Okay, and then we solve it out so that we can find out Ws. Okay, so this was our question. I think you have understood. Just here the twist was that we have to find out the Vd in terms of Vp and Vl, then only we can replace in this part, so that we can solve it out, okay, and get Ws. So this was your problem. Then again the second part, shrinkage ratio. You just, I remember perhaps I had already told you the formula V1 minus V2 upon Vd into 100 upon W1 minus W2. Here in this case we can choose it to be Vd only, or volume at shrinkage. Okay, so V1 upon V1 VL minus Vd upon Vd into 100, again just put the values to get R equals to 2.27. This is nothing hard, it is just generalized, just we have to put the values and solve for the numerical value. Okay. Now this is another question, this is depending upon the activity. If you remember, what was activity? Activity was IP upon percentage of clay. Okay, percentage of clay. So what are we given with? Two clay soils have the following characteristics, calculate their activity and compare their engineering behaviors. So we are given with WL for both soil, again WP for both soil, again IP for both the soils, finally this is clay fraction. Okay, what does this mean? This part, this is actually corresponding to clay, because clay is always less than 2 micron. Okay, so this is the same. So finally what we are given with, IP is given to us and fraction, means both of these are given to us, this and this. We can directly apply the formula. Okay, activity of soil A will be IP upon this. So you can say 35 upon 25, which is 1.4. Again for clay B, IP upon clay fraction 20 upon 40 will give you 0.5. What does this mean? The activity of clay is more than that of the clay B. Clay A has the more activity. Activity for A is greater than activity of B, because it is 1.4 nearly and it is only 0.5. Okay, so 0.5. So you can say this is more active than this. It has more clay particles than this. Okay, it has more soiling property than this. Okay, you can say that clay A, therefore clay A is more likely to undergo high volumetric change. Okay, means soiling property will be higher in clay A. Clay A has higher compressibility than B, because it is soiling higher. So when you remove the water from the soil A or clay A, more compression will be taking place. So the same is being conveyed here. Then the permeability, but remember this point, the permeability and rate of volumetric change are smaller than that of clay B. Means in clay B the volume change rate, okay, rate, remember, not the total volume change, only the rate of volume change, and the permeability will be higher than clay A. Okay. So this was it. This is a easy question. So, this is it. Now, next turn we will be discussing about some other topics such as compaction, okay, compaction of soil, and we will be talking about how the compaction takes place and what are the things used and what are the phenomena going under it and all. Okay. So, please be connected with us. Thank you.